Good morning, students. Today we are going to discuss exercise 9.3, and today we are going to do the third part, that means question number 9, 10, 11 and 12. So this is question number 9. In this question we have the side AB of a parallelogram ABCD is produced to a point P. So it is produced to a point P. A line through A and parallel to CP meets CB produced at Q. So CB, this line is produced to Q, and this line AQ is parallel to CP. And then parallelogram PBQR is completed. Show that the area of the two parallelograms at ABCD and PBQR are equal. So we have to show this. So here we have constructed two lines AC and PQ. In the diagram, in the given diagram, we have joined two lines, that is AC and PQ. In this question, we are getting two triangles, that is triangle ACQ and triangle APQ. So the triangles are like this: ACQ, ACQ is one triangle and APQ is the other triangle. So here is C, A, P, P and Q. So this is those two triangles who are on the same base AQ, and this line AQ is parallel to CP. So this line AQ and CP are parallel. This is given in the question. So the area ACQ and area APQ are equal. Now from this areas we are going to subtract this part out, that is ABQ, we are going to subtract it out. So we will get area ACQ minus area ABQ is equals to area APQ and minus area ABQ. So whatever we are left with ACB and BPQ. So we have area ACB and area QBP. So this is our first equation. Now since AC and AQ are the diagonals of the parallelogram. So if we see the parallelogram ABCD, AC is a diagonal, and if we see the parallelogram BPRQ, QR is the other parallelogram. So we can conclude that area ABC is equals to half of area ABCD, and also area QPB is equals to half of area ABCD. So from this three equation 1, 2 and 3, we will get half of area ABCD is equals to half of area PBQR. We will cancel half and half, so we'll get area ABCD is equals to area PBQR. So this is proved. Now question number 10, we have diagonal AC and BD of a trapezium ABCD with AB parallel to DC intersect at O. So we have a trapezium. In this trapezium, AB is parallel to CD and the diagonals BD and AC meet at O. So we have to prove triangle AOD. So this triangle is equals to area of BOC. So here is the diagram. We can see that the triangle ADAC and triangle DBC. So the triangles are like this: DAC and DBC. DAC and DBC are like this, are on the same base DC and between the same parallel lines AB parallel to CD. AB is parallel to CD is already given in the question. So the area of the two triangles are equal. Now from this two part we are going to subtract DOC. So from the area of DAC minus DOC, and from the area DBC we are going to subtract DOC. We are going to be left with AOD, area of AOD and area of the triangle BOC are equal. And this is our question number 11. In this question we have ABCDE is a pentagon. So ABCDE is a pentagon. Pentagon means the quadrilateral having, it is a five-sided figure. It is not a four-sided figure. So it's not a quadrilateral. It is a five-sided figure known as pentagon. A line through B parallel to AC meet DC at F. So DC is produced to F and the line BF is parallel to, the line AB is parallel to CF. We have to show that triangle ACB is equals to triangle ACF and a parallelogram AEDF. This parallelogram is equals to area of the pentagon, that is ABCDE. So here is our diagram. The diagram was already given in the question. So the first one, we will consider the triangle ACB and ACF. So ACB is like this and ACF is like this. So A, C, B and F lies on the same base AC and have same parallel lines AC parallel to BF. So AC and this line BF are parallel to each other. So we will get the areas are equal. So the triangle ACB is equals to the triangle ACF. So the first one is proved. Then it is said that it can be observed that ACB and ACF are equal. So to it we are going to add ACDE. This quadrilateral we are going to add to the triangles. So on adding ACDE to ACB, we are going to get the pentagon, that is ACBDE. And to ACF, if we add the quadrilateral ACDE, we are going to get a quadrilateral AEDF. So our second proof is also done by simply adding a quadrilateral to the first proof. So this is the last question for today, and the question says, a villager Itwari has a plot of a land in shape of a quadrilateral. The Gram Panchayat of a village decided to take over some portion of his plot from one of the corner to construct health center. Itwari agrees to the above proposal with the condition that he should be given an equal amount of land in lieu to his land and adjoining his plot so as to form a triangular plot. Explain how is this proposal implemented. So this is the figure. ABCDE is the quadrilateral that was originally the field of Itwari. The proposal was implemented as follows. So this was the diagram where, or the plot of Itwari, where the panchayat wanted a triangular plot of his land. So we have to join BD first and draw a line parallel to BD through point A. Let it meet to the extended of CD at E. So we have a figure like this. So we have to join this line BE and it intersects at O. Let them intersect each other at O. Then the portion AOB can be cut from the original land. So AOB is the part where, this part is the part where the government will take away, the panchayat will take for the construction of health center. So instead of this portion, he should be given another plot in lieu, that is adjoining to the land, which will make a triangular figure. So B, this part OED, this part is the part which is being awarded to him, so that he have a field in triangular figure BEC. So here we have to prove that the area of AOB, that is a portion that is cut out for the health center, should be equal to EOD. So the portion that is shaded should be equal to the part EOD. Okay, so here we can observe that DEB and DAB, this lie on the same base BD. So the triangles are like this. DEB is one triangle and DAB is the other triangle. Here we have B, A, E and D. This is the part. So they lie on the same base BD, and BD is parallel to AE, which is given in the question. So we will get the areas of the triangle as equal. So DEB is equals to area of DAB. Now from this part we are going to cut off DOB. So this part will be cut off. DOB will be cut off. So in from both the side of the triangle, so we are left with triangle DEO, which is equals to AOB. This is what we require to prove, because AOB is the portion where the government takes away, and instead of it the government gives him OED, which is of equal area. So this is how question number 12 is done. So today we discuss question number 9, 10, 11 and 12. I hope this tutorial is helpful for you. Thank you.